All right, section 510 is on arithmetic and geometric sequences. When you first started math of any sort, you probably worked on doing patterning. And so you could look at a group of patterns and you could go circle, triangle, diamond, circle, triangle, and you would know that the diamond would have to come next. Well, numbers also can have patterns to them. So if I look at this group of numbers, I have a 1, 2, 4, 7, 11, and I try to figure out the pattern between them. That's plus 1, plus 2, plus 3, plus 4. So I would need to do plus 5, which is going to be a 16, plus 6, which would be a 22, plus 7, which would be a 29. So those would be the next three terms in that pattern or sequencing. There are specific types of patterning or sequencing that we're going to talk about in this section. And the first type is called an arithmetic sequence. It is a pattern where the difference between any two consecutive numbers, which means numbers right in a row, is the same. So if you look at this particular sequence, you would see that I am adding a -3 between each number. That's what we would call their common difference. So when I add a -3 to the -4, I get a -7, a -10, and a -13. Those would be the next three numbers in that arithmetic sequence. Now remember, arithmetic, you have to be adding, or if you will, subtracting the same thing each time. On this one, looks like it's the same thing. It's -3 in between each, which is going to make this a -16, a -19, and a -22. Okay? Remember, there has to be a common difference for it to be an arithmetic sequence. Let's do a few practice problems here. If I'm going between -5 and -1, looks like I've added a 4 between each one of these. So I know it's an arithmetic sequence, so the answer is yes. Okay, if they were different numbers that I add between each one of them, the answer would be no, it's not an arithmetic sequence. So the next number would have to be 15, and then 19, and then 23. This one, let's see, I've added a 2, I've added a 4, and I've added a 6. Now notice there's a pattern, but it says, is it an arithmetic sequence? Well, you haven't added the same number between each of those numbers, so therefore the answer is no. This is not an arithmetic sequence. Another type of patterning or a sequence is called a geometric sequence. And that is a pattern or sequence where the quotient between any two consecutive terms right in a row, is the same. In other words, they have a common ratio, or another way I can put it is I multiply by the same thing between each terms. So I multiply by -3, -3, -3, because -2 times -3 is +6. +6 times -3 is -18. -18 times -3 is 54. So I want to multiply again. 54 times -3 is going to be -162, which I'm going to multiply by -3. And it's going to give me 486, which I'm going to multiply by -3, which is going to give me -1458. So between each one of these, I multiply by -3. That makes it a geometric sequencing. Geometric is multiplication, arithmetic is addition. So these, to go from 20 to 10, I would have to multiply by 1/2, because I'm literally taking half of each number. Okay? Which makes it a geometric sequence. So this one's going to become 5 over 8, 5 over 16, and 5 over 32. Because I'm multiplying by 1/2 between each one. And that's what makes it geometric. Okay, let's practice some of those. Looks like I'm going to be multiplying by 1/3. Okay, you can always find it by dividing the one past it. So I can take, and it looks like it's a negative 1/3. I can take 3 divided by -9, and it's going to give me a negative 1/3. That's how I can find their common ratio. So again, multiplying by negative 1/3, negative 1/3. So that's going to give me a negative 1/9. And then that's going to give me a positive 1/27th. And a negative 1, let's see. Negative 1 over 81. Alright, this one, I'm going to divide 3 by 1. So what I'm doing is I'm multiplying by 3. So 27 times 3 is 81. 81 times 3 is 243. And 243 times 3 is 729. Alright, your homework on this is page 251, 10 through 27 all. Hopefully it'll focus on that. It didn't focus in very well. Hopefully you can see that. There you go. Page 251, 10 through 27 all.